Hello students. So today we are going to discuss some of the problems on the gravitation chapter. So before starting the problems, let us summarize what are the formulas we have discussed based on mass of an object, weight as well as weight of an object on the earth and weight of an object on the moon. Under that, the first formula which we have discussed is, since you know weight of an object is equals to mass into acceleration due to gravity, that is W is equals to m into g. That is the first formula. Second formula you know, that is weight of an object on the moon is equals to 1 by 6 weight of an object on the earth. That is Wm is equals to 1 by 6 We. Using these two formulas, we are going to solve the problems. Okay. So under that, first problem is mass of an object is 10 kg. What is its weight on the earth? Okay. So since mass of the object is given, so here m is equals to, first you have to write what are the things given. Mass is 10 kg. What is its weight on the earth? That means you have to find weight of an object on the earth here. Okay, here they have not asked what is the weight on the moon. Okay, if they have asked what is the weight on the moon, means first you are going to find weight of the object on earth, then you are going to find weight of an object on the moon. Since here only the one term is given, that is weight on the earth, so we are going to use the formula, since you know W is equals to m into g, that is mass into acceleration due to gravity. Since you know acceleration due to gravity formula, that is 9.8 meter per second square. This is the value of acceleration due to gravity. So now let me write it. We is equals to mass is 10 into g value, it is 9.8 here. So 10 into 9.8 means 98. So this is the weight of an object on the earth. Since you know what is the unit of weight here is Newton. That is, weight is nothing but force of gravity. Okay. So this is the answer for the first question. So now let me go with the second problem. An object weighs 10 Newton when measured on the surface of the earth. That means an object, you consider a stone as an example. So weight of that object on the surface of the earth, that is on the earth, it is We is equals to 10 Newton. Okay. What would be its weight on the surface of moon? Okay, now it is a comparison between the earth as well as the moon. So we have to know weight of that object on the moon. That is the question mark. So since the formula here is Wm, that is weight on the moon, is equals to 1 by 6 weight on the earth. That is 1 by 6 into We. I can change this as We into 1 is nothing but We divided by 6. So weight on the moon is equals to We by 6. So what is We here? 10 Newton, that is weight on the earth, divided by 6 here. So 10 divided by 6 means you are getting answer as 1.67. And what is the unit here? Unit weight, unit is always, it is Newton. Whether it is a weight on the moon or whether it is a weight on the earth, the unit will remains as it is. Okay, so this is about the second problem. So now let's go with the third one. Since the third question says weight of an object is 294 Newton on the surface of the earth, what is its weight at the height of 200 km from the surface of earth, given radius of earth is 6400 km. Okay. So first let me write what are the things given here. Weight of an object is given, that is on the surface of the earth, means I can consider as We is equals to 294 Newton. Okay. What is its weight at the height of 200 km from the surface of earth? They are not saying about any of the other planets or any of the moon. They are only saying above the surface of earth. For instance, I'll consider this as the earth. Okay. This as the earth here. Here in the center, you consider an object is placed there. Now, for example, they are asking that what is its weight at a height of 200 kilometer from the surface of Earth. So this is the surface of Earth if you have considered. From this surface 200 kilometer above, that means above this surface of Earth, after 200 kilometer, that is above this 200 kilometer from the surface, what is the weight of that object? Same object we want to consider. So what is the weight of an object when it is on the surface of Earth? Similarly, what is the weight of an object when it goes above this 200 kilometer from the surface of the Earth? Okay, so here the object is placed, that is 294 Newton object is placed here on the surface of the Earth. The object is placed, that we were getting the weight as 294 Newton. When I take the same object in this position, that means at 200 kilometer above the surface, what will becomes its weight here? Okay, so now another one parameter here is given is radius of Earth is given, that is RE is equals to 6400 kilometer. Okay, so radius is given means from the center to this point, the radius is given as 6400 kilometer. Okay, from the center of Earth, you know, from the center of Earth, that is nothing but from the gravitation of the Earth, from center to the surface 6400 kilometer plus 200 kilometer above the surface. Now what is the total distance now? Okay, total distance here it takes place 6400 kilometer plus 200 kilometer. If you add, you will get the total distance, which or the total distance which is the weight of that object at 200 kilometer above the surface. So 6400 plus 200 kilometer. So 6400 kilometer plus 200 is nothing but 6600 kilometer is the total distance between the center of the Earth and the height of the certain height. I'll consider this as height A. Okay. Now we have to consider what is its weight at 200 kilometer. Weight at 200 kilometer I want to consider. That I am considering it as WH here, because weight at certain height I am going to consider as WH. Weight on the Earth is WE. Now here what is the, here you can't use the formula that is WE is or WM is equals to 1 by 6 W, because that is for the other planet, that is like moon, we are considering that. So that is why what is the weight? Here weight is nothing but force. So what is the unit for the force, or what is the formula for the force here? So WE is equals to GMEM divided by RE square. Okay, so why I am using this? WE is nothing but weight of an object on the Earth is equals to GME. ME is mass of the Earth into mass of the object divided by radius of the Earth. Why I have considered this formula means, you know, weight is nothing but force of gravity. Force of gravity means, what is the formula for the force? GMEM divided by RE square. Now let me take this as equation number 1. This is weight of an object on the Earth. Now let me consider weight of an object at the certain height. Since capital letter G is constant, mass of the Earth. Here we are only considering about the Earth. We are not considering about any other planet. So it will be ME itself. So, and mass of the object. You know, since mass is constant wherever that object will go. So M is also a constant divided by D square I will consider, because radius plus certain distance. So that is, this is the D square here. So now let me take this as equation number 2 here. So what we want here, we want this WH value. So if I divide WE divide by WH, then I'll get WH. Why? Because since we have known that what is the value of WE. So I have substituted the value, that is WE divided by WH is equals to GMEM divided by RE square divided by GMEM divided by D square. Now let me change this GMEM m divided by re square. When this denominator goes to numerator, this become d square will comes to numerator, and this em comes to denominator. Now you can see that g is a constant, so I can cancel this constant. Mass of the earth is constant for both whether it is on the surface of earth or at the height of 200 kilometer. The mass will remain same. Mass of that object, that also remains constant. So this constant will get cancelled. So what is the remaining here? D square divided by re square. Okay, so we by wh is equals to d square by re square. What is d square here? D square here is nothing but 6600 whole square divided by re square. Re square, what is the value of re square? Radius of earth, 6400 whole square. Now let me simplify this. So let me take it E divided by WH is equals to 6600 whole square divided by 6400 whole square. Okay. Since weight of an object on the surface of earth is given, that is 294 Newton. Let me substitute 294 divided by weight of an object at certain height is equals to 6600 whole square divided by 6400 whole square. Now let me do the cross multiplication. So if I do the cross multiplication, so WH into 6600 whole square is equals to 6400 whole square into 294. So WH is equals to 6400 into 6400. I'll consider whole square is nothing but it is 2 times multiplication into 294 divided by 6600 into 6600. If we simplify this, you will be getting an answer 276.45 Newton. Since the unit is Newton here, so weight at certain height is 276. Approximately, I will consider as 276 Newton. Okay, why I am considering this means, see here. Here the weight on the surface. Let me draw it once again and I explain you. So here on the surface of the earth, the weight of that object is 294 Newton. When you go higher to certain distance of 200 kilometer, its weight has become 274 Newton. See here the difference. 294 is there. When you go higher and higher, the weight of that object goes on decreasing. Why this weight has been decreasing? You know the formula for the weight. Weight is equals to mass into acceleration due to gravity. Since you know this mass remains constant, if you consider any of the object here or that object, same object here, means the mass of that object remains constant. But where this value of weight goes on decreasing, as that value goes on decreasing due to g value. G value is what? Acceleration due to gravity. So what I can conclude from this means the acceleration due to gravity, that is g value, goes on decreasing when you go higher and higher. That means above the surface of the earth, the value of g goes on decreasing. On the surface of the earth, we can able to say that this g value is exactly 9.8 meter per second square. But when it goes higher and higher, this value, g value, goes on decreasing. Since g value goes on decreasing, even though the mass is constant, but the weight of that object is decreasing. So we can conclude that g value goes on decreasing as it goes higher and higher. Okay, I hope everyone have understood this question. So very important topic it is. So if any doubts is there, we will discuss in a live session. So according to this problems what I have solved in this class, based on that I have given you the worksheet. Try to solve it. Thank you.